Hello, once again I welcome you to the video lecture on transformers and generators. So let us begin with the third module of transformers and generator. Again, third module consists of three subparts. First part, it consists of three winding transformers and cooling of transformers. Second part is direct current generators. Third part is synchronous generators. So in this video, let us study three winding transformers. That is introduction regarding three winding transformers and equivalent circuit of three winding transformers. So till now whatever we studied, so those are two winding transformers and single winding transformer. That is single winding transformer is called as auto transformers. So usually such type of construction, that is three winding transformers, can be constructed for higher rating transformers. So the third winding is called as the tertiary winding here. Because of three windings, the transformer is called the three winding transformer. But what about the voltage rating of all the three windings? So usually the voltage rating of three winding transformers are usually unequal. The primary winding has the highest voltage rating, the tertiary winding has the lowest voltage rating, and the secondary winding has the intermediate voltage rating. Now the main advantage of a three winding transformer is that the economy of construction and their greater efficiency. So it gives the higher efficiency, and construction of such type of transformer is what it is economy. The schematic diagram or the representation of the three phase transformer, three winding transformer is as shown here. So this is a three winding transformer. So see, so this is a core. So all the three windings are wound on a single core. See, so this winding it is represented as what, T1. So this winding it is represented as what, T2, and this winding it is represented as T3. And whatever be the voltage drop across the winding, so that is represented as so this is V1, V2 and V3. So respective currents are I1, I2 and I3. So here the winding representation, so usually the primary and the secondary windings are connected in star fashion, and the tertiary winding it is connected in what, delta fashion. See, this is the water T1, this is the water T2, so this is water the T3, so this is water the tertiary winding of a transformer. And the transformation ratio of all the three winding transformers are given here. So this is what the transformation ratio of the primary and the secondary winding. So this is V2 by V1 is the voltage ratio, T2 by T1 is the what, turns ratio, and here so this is the transformation ratio with respect to tertiary winding with the primary winding. This is V3 by V1 is equals to T3 by T1, and in general we can write, considering all the three winding, the transformation ratio can be represented as I1 T1 is equals to I2 T2 is equals to I3 T3. And the most significant advantage of the third winding is that are the harmonic generated by the primary and secondary winding extinguished by the third winding. So the main advantage of tertiary winding is that it suppresses the harmonics. Obviously, as you know that the drawback of the harmonic, so obviously, so the suppression of harmonic it plays a very important role, since the tertiary winding it does that it suppresses the harmonic generated by the primary winding. Usually you know that the third winding, that is the tertiary winding, it is connected in delta fashion, and the voltage of the tertiary winding differs than the primary and the secondary winding. Thus, it is used for supplying the primary to the auxiliary appliances like the fan, tube, light, etc. of the substations. So this tertiary winding voltage rating, it is differ as that of what primary and secondary winding, since it is used for supplying the power to the auxiliary appliances like the fans, tube, lights, etc. Some appliances so that are used in water substations. Now the tertiary winding, where the tertiary winding can be used. So these are the some applications of the tertiary winding. So first application is that the reactive power compensation. So that is the reactive power is supplied to the substation with the help of the tertiary winding. So tertiary winding can be used for the water, the reactive power control. And one more application is that the tertiary winding reduces the impedance of the circuit so that the fault current easily passes to the ground. So obviously this tertiary winding also it reduces the impedance of the circuit. If the you know that impedance of the circuit it reduces, obviously whatever be the fault generated in the system, so that generated fault will be what it is bypassed through the water ground. So it is useful for the reduction of the impedance of a circuit. So one more application is that it is used for testing the high rating transformers. So these are the some applications of the tertiary winding. This is regarding the three winding transformer. Then what about the equivalent circuit of a three winding transformers? So as you know that the equivalent circuit of two winding transformer. So this is similar as that of what the two winding transformer. So this is the equivalent circuit representation of what three winding transformers. So this is what the primary winding you can consider, and you can consider this is a secondary winding, and this is the what the tertiary winding. See, obviously you know that each winding it consists of what the respective resistances and reactances. So the combination of these two we can represent it as what the impedance. And so this one R naught and X naught so are the no load component of reactance and the resistances value. Obviously with respect to this current will be no load current, this is represented as I naught. So obviously you know whatever be the current which is flowing through the water, the resistive value of the component and reactive value of the component. So those currents are called as what? The core loss component and the backfill component. So this can be represented as what? So this IC and IW. So these are useful for the water, the reduction in the water loss component. So here we considered R1, R2 and R3 are the resistances, and the X1, X2, X3 are the impedance of their windings respectively. And the voltages V1, V2, V3 and the currents I1, I2, I3 which flows through their respective winding. So this is what the equivalent circuit of a three winding transformer. Let us consider stabilization by tertiary winding of a transformer. So how the stable operation can be achieved by considering the tertiary winding of a transformer. You know, for unbalanced single phase load, the star-star connection offer high reactance to flow of current. So obviously, as you know that the uh, balanced condition it plays a very important role in a system. For unbalanced single phase load, so here the star to star connection, so that is both primary as well as secondary winding star connected. So both the winding offers a very high reactance to flow of current. So if you consider any unbalanced load current, so these load currents can be divided into three components. Those are positive sequence component, negative sequence component and zero sequence component. And the zero sequence component on the secondary side, which cannot be balanced by the primary current, as zero sequence current cannot flow in the isolated neutral of star connected primary. So if the zero sequence component in the secondary side, so which cannot be balanced by the primary current. So because, so which cannot flow. So this is what the isolated neutral of what star connected what primary. So this is very difficult to balance such type of zero sequence component which is on the secondary side of a transformer. On the secondary side, the zero sequence current sets up a magnetic flux in the core. So this zero sequence component which sets up the magnetic flux in the core at a secondary side. So due to this flux, the iron path is available for this flux and the impedance offered to the zero sequence current is very high. So whatever be the zero sequence component on the secondary, so which sets up the magnetic flux on the uh, iron path of a core, so which offers the impedance, very high impedance, but the delta connected tertiary winding permits the circulation of zero sequence current in it. So here the tertiary winding, if there is a zero sequence component, so what it does, so it permits circulates the zero sequence component of the current itself. So here it will not circulate the zero sequence component of the water current. That means here the zero sequence component current will be what it is suppressed here. So here not. So it sets up its own magnetic flux on the core. So due to that, so this secondary winding which offers what the greater impedance. So due to this greater impedance, obviously, so here what the secondary current will be what it is reduced. So here that is given. So impedance offered to the flow of zero sequence current is lowered. So here due to the impedance offered by the zero sequence component, greater the impedance offered by the zero sequence component, obviously the current will be what reduced. So since so the tertiary winding, so it suppresses this zero sequence component because it is delta connected. So whatever be the zero sequence component current, so will be circulated within the tertiary winding. So it will be suppressed. So since so this tertiary winding, it is useful for the stabilization of what the transformer. So this is regarding stabilization by tertiary winding of a transformer. So in next video, we'll come up with some more bits of this three winding transformers and cooling of transformers. Till then, take care.